Hello. The purpose of this video is to look at two different ways of laying out our polynomial multiplication. And one method is called the area model, and it uses the area of rectangles to model what we're doing with our polynomials. And the other is more a straightforward distribution where you distribute the multiplication from one parenthesis over all of the terms in the other parenthesis. And I was taught with distribution, but I currently teach using the area model. And I think it's beneficial to look at both, especially if you're in a class where the teacher is using one of these strategies or ways of laying out the multiplication, but you are more comfortable using another strategy. It can develop your ability to go back and forth between the different ways of doing it. So for this example right here, we have 2x plus 5 times x minus 3. On the area model, what we do is we picture each of these as being one of the dimensions of a rectangle. And so we might have 2x plus 5 is the base. And so we would put that up here as 2x plus 5. And that essentially measures the length of the rectangle there. And then the other one might be the height. And so we would put x minus 3 as the dimension on the height. And what we're looking for is now the area. So if I do the base times the height and I find the area, well, the way that we find the area is we find the area by finding the area of each individual square here and then adding them up. And you'll notice that the way that we've done that, each square has a base and a height. So this first square, we have a base of 2x and a height of x. Well, 2x times x is 2x squared. This next rectangle or square, I guess it's a rectangle, but we draw them as squares, has a base of 5 and a height of x. And so 5 times x would be 5x. So the area of that section is 5x. Now we have a base of 2x and a height of negative 3. So this area here would be negative 6x. And then the last one has a base of 5 and a height of negative 3. So 5 times negative 3 is negative 15. And then the overall area, so remember we're looking for the overall product. And so the overall area would be the sum of those. And usually when I first start doing this, I'll write it all out, like we're going to add all of those up, and then we'll combine the middle terms there. And so we'll get 2x squared minus x or minus 1x minus 15. But typically I would skip this step, okay? So I'm going to go back in and just kind of erase that. Normally when I'm doing it this way, I would not write that. And instead what I would do is I would kind of circle this or look at it and simply know those are my like terms. Those are going to combine together. So negative 6x plus 5x, and I would go right to the negative x or negative 1x. Okay, and that's how that multiplication looks on the area model. To do this with distribution, and usually when it's a binomial times a binomial, instead of using the word distribute, you might have had a teacher use the word FOIL. And FOIL is an acronym that simply means first, outer, inner, last. And it's a way of remembering what you have to multiply. And so you would multiply the two first terms. So 2x times x, that would give you 2x squared. Outer means the two outside terms. So 2x times negative 3, which would give you negative 6x. Then you would do your inner, so that's the I in FOIL, is the inner 5 times x, which would be 5x, and then last, so that would be the 5 times the negative 3, which is negative 15, and then 2x squared, and then we have the like terms right there, negative 6x plus 5x, which would give us negative x minus 15. Now, we've used the word FOIL so much that it's almost become a verb. Like instead of just this acronym that reminds us first, outer, inner, last, we talk about foiling stuff together. Like we've turned it into a verb and say, okay, we're going to take these parentheses and FOIL them. Now, it's a nice little acronym. And if you have trouble remembering what you're supposed to multiply, certainly first, outer, inner, last can help you. But it's also very limited. What you're actually doing there is distributing. And so I'm going to use some different colors so you can see what is actually happening. You're taking the 2x and you're distributing the 2x over the other set of parentheses. And that's where you're getting your first and your outer. You're just distributing the 2x, and then you go through and distribute the 5. And that gives you your inner and your last. So really what foiling is repeated distribution. You take everything in that first set of parentheses and you distribute it one at a time through everything in the second set of parentheses. Now, looking at the two strategies side by side, you should recognize that you're getting all the same terms here. So you have a 2x squared and a 2x squared, negative 6x, negative 6x, 5x and 5x, and a negative 15, negative 15, and you're combining the terms. So really, it's the same process. It really is the same process. The only thing that's different is how you're laying it out on the page and how you are mentally picturing what you're doing. Okay, so it's the mental game and the mind game and the layout on the page. Now, in Algebra 1, and probably in all of math, this is the most common. Okay, we will see uglier polynomial multiplication, and I'm going to show you one on the next slide, so you can see some of the advantages of using the area model. But this is the most common one, okay, multiplying two binomials together. And for me, I was taught this method over here, and I've done it so much that I'm actually really fast at it, and I don't need to do that middle step. So most of the time when I'm multiplying binomials, I can kind of hold enough numbers in my head and I can get there really fast, and I wouldn't bother writing this, nor would I bother writing out the rectangles. Now, if you're new to it though, and you're just learning it for the first time, you're probably going to need to show some work. Okay, so me with 30 plus years of experience doing this is not the same. Like certainly when I first started doing it, I had to write more stuff out. Okay, so let's take a look at a nastier problem. So this is a trinomial times a trinomial. And if you study this in class, you know that if you have 3 times 3, you're going to have 9 of your smaller terms, and then you'll have to combine like terms. So the area model will still work. It just gets bigger, okay? So you have a bigger rectangle that you need to divide up. And once again, you have a base. So 2x squared plus x minus 3. So we'll make that the base. And then the other dimension, the x squared minus 3x minus 4 is the height. And now we're just going to do all of the little multiplications and then add them up to get the total area. So 2x squared times x squared is 2x to the 4th. X squared times x is x to the 3rd. X squared times negative 3 is negative 3x squared. And again, what the idea there is that we're finding areas. We're multiplying the base times the height to find the area of each of the smaller ones, and then the total product would be the area of the whole thing. Negative 3x times 2x squared is negative 6x to the 3rd. Negative 3x times x is negative 3x squared. Negative 3x times negative 3 is positive 9x. And then filling in that last row, 2x squared times negative 4 is negative 8x squared. Negative 4 times x is negative 4x. And negative 4 times negative 3 is positive 12. And I mentioned I don't usually write out the big long list because when you're using the area model, your like terms, the things that you're going to be able to combine together, are going to be very close to each other. Now, they're often on the diagonals. Okay, so if you look at this, you've got your x to the 3rds that are on a diagonal. You've got your x squareds that all land on a diagonal, and then your x's, and then your lone rangers end up in the 2 corners. Okay, the things that don't have anything to combine with. Now, I can't guarantee you that that will always happen. That happens if both polynomials are in standard form and you don't have any missing terms. So you don't go from like a 2x squared and you skip over the x and just have a constant, okay? But it happens a lot, okay? And even when they are not all on the diagonals, they will be physically close to each other in your rectangle. So let's go ahead and write the answer to this. So this would be 2x to the fourth minus, so negative 6x to the third plus x to the third is negative 5x to the third. Now, for some of you, you might need to grab a calculator and do this. Negative 3 plus negative 3 is negative 6, and negative 6 plus negative 8 is negative 14. So that's negative 14x squared. This is 9x minus 4x, or 9x plus negative 4x. So that is 5x, and then plus 12. Okay, and notice that we have the 9 individual terms and then some of them combine, and we end up with that. So that's what that looks like on the area model. And I'm sorry that there's dinging. I am expecting an important phone call, and so the volume on my phone is turned up. It's sitting here next to me. Normally I would silence it, but okay. Now to do this with distribution, FOIL doesn't work, because instead of like first, outer, inner, last, like now you have middle terms in there. So you've got first and last and middles, and FOIL doesn't cover all that. So you've really got to go back to distribution. We are going to distribute everything in that first set of parentheses over the second set. So that first distribution, we're going to take that 2x squared and we are going to distribute it over everything in that second set of parentheses. So 2x squared times x squared is 2x to the fourth. 2x squared times negative 3x is negative 6x to the third. 2x squared times negative 4 is negative 8x squared. And then we've got to repeat that distribution. So we've got to do distributing again, just this time with the x. So x times x squared is x to the third. X times negative 3x is negative 3x squared, and x times negative 4 is negative 4x. And then we've got to do another distribution because we've got to distribute the negative 3, and so we've got to do that. And so it really is just repeated distribution. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 3x is positive 9x, and negative 3 times negative 4 is positive 12. And I want you to notice a couple of things about this. First of all, it is all of the same math that you did on the area model. It is just laid out differently on the page, okay? And so you can see these 9 terms that I have here are the same 9 terms that you have over here. And just like we did over here with the area model, we have to combine them all together. So you've got to go through and find the like terms. Well, there's no 2x to the fourth. And what I used to tell my students when I taught it this way is I would tell them, once you cover something, like just kind of draw a line through it, cross it off. Now you've got to find your x to the thirds. So negative 6x to the third plus x to the third is negative 5x to the third. And again, we're just going to cross those off. Now we have our x squared. So negative 8x squared minus 3x squared is negative 11x squared minus 3x squared is negative 14x squared. And we want to make sure we get those. Now we have our x's. Negative 4x plus 9x is 5x. And that leaves me with the 12. Okay, both of those methods work, but I mentioned earlier, I am an advocate of the area model, and looking at these bigger problems, it's a little bit more obvious why. First of all, the area model is going to compact your work into a friendlier shape and size of space. So it is the same amount of writing, okay? Like you have the same amount of writing here, but the distribution stretches it out. So it's actually pretty long. My blue down here got a little bit cramped, where the box just uses your space better, okay? The other thing I mentioned is in the area model, your like terms are going to be situated near each other. And if you look at this one, like my x squareds were all over the place. Like you kind of have to look here and then scan. Oh, there's another one. Oh, there's another one. And they're not near each other. And that's why I would tell my students, you cross them off, because it's very easy to just leave one out. The other thing is when you lay out this grid, you are not going to accidentally miss one of your multiplications. There's 9 different multiplication problems that need to be done, and you're not going to miss one, because if you miss one, you'll have an empty box. Where when you're doing it this way, your eye has to track left to right, and you're always bouncing your eye back and forth, and it's very easy to miss one of the multiplications. So you end up with 8 terms, and you just don't have one, and you don't catch it because there's not a blank there that's going to be staring at you. So I am an advocate for the area model. It is what I ask my students to use, but I know like other teachers do other things, or students might be, just have personal preferences for different ways. So now you can see them laid out side by side. You can see how it is exactly the same process, it's just a change in the format, how you're positioning it on the page. So I hope this helps clear up any questions you have about the area model and how it relates to other ways that we visualize our multiplication, and that you're able to go back into your own math class and do this however your teacher is requiring you to do it. Check out some other videos on the channel, and I hope to see you in a future video.